So today we're going to learn about how to basically retrieve nodes that are reachable from the root, and we're going to use depth first search. Very similar to breadth first search, but basically instead of using queue, we're going to use stack. Okay, so first in first out type of data structures. And so let's look at basically the graph, like how it's going to look like with similar to the breadth first search. We're going to push it on the stack, pop it out, and compare with the nodes and the basically the relationship, and making sure that this is each nodes are connected, and we will count them right here down here, and we will get the solution something like this. And basically we will go up, and while we're counting that, we also will count nodes that are reachable from the root itself, which is 0. And that's what we're going to do for this depth first search. And this data structure is basically adjacency matrix, so it will be easy to understand how what we're trying to do. So okay, so very similar to breadth first search, and let's first thing first, we're gonna we will want to have a variable called node length. So that's the length that we're trying to get, and that will be really awesome for us to calculate the length first. And then we're going to have visited, and that's the basically the one that we're going to return. And also we're going to need stack, and that stack will contain the root. So just like queue, we're going to need that, and we will push visited the root right here first, because that's the one that first visited, right? We don't have to calculate anything, so the root will be the first that we visited, and that will be the first that we have to push. Okay, so now we will have to initialize node lengths, okay, with infinity. And so for and var and node equal to 0, and node less than graph.length. All right, and node plus plus. So we will initialize that node length, and node to infinity there. So infinity, what was I saying? Is not defined. Node length. Okay, now reference 0. Infinity. Why? Interesting. It is not defined. Oh, okay. So infinity. That's what I said. Infinity. Okay. So after that, after initializing this, we will have to basically calculate the node length. So while the stack dot length is greater than 0, then we will have to calculate the node length. So for var current, and we will have to pop it, the first one that we just enter, which is basically root right here. So that's the root that we're popping, and now we're going to calculate each node from the column, right? So, and check if there's a distance. Okay, so now var just like we did above, node equal to 0, and node less than graph, so each column, so we have to use current, and then length. Makes sense? Okay, so node plus plus. In this case, instead of node, we can use column, but yeah, it's just the same. Okay, so And then if we're going to use that, and let's return and check if solution is correct first, the node length. Yeah, so that way we can check if we are doing correctly or not. So if functions will take care of checking if there's any relationships between each node. So in this case, graph will compare, so something like this, and node, and it has to be 1, and graph, not graph, so 1, and also node length has to be so edge not match node go to infinity. So if it's empty, then we are pushing it, right? Graph dot not graph, node length, and node basically calculating the distance. So in this case, node length that will be our current, and then plus 1. Okay. Oh, and also we forgot to mention, since we already know that the root itself is 0 distance, right? We can just say, just like we did right here, and just do it right here. We can just say that, hey, node length root is basically 0, right? So yeah, so in this case we can say that 0 distance right here. Okay, so that's the root, and stack dot push, we're gonna push the node that we just found out, so it's gonna go up to each node. So that's what we're doing, and then yeah, so stack node has to be this right here is wrong. It's supposed to be current. Okay, so current, yeah. So now the graph is going from the column, each column, and compare and check the node length is this empty or not. So, right, is it empty, then calculate the number, and also we can take the previous distance and then calculate from the root to each node. That's the distance. All right, and then visit it. That's the one that we're trying to return, right? So since this is not the one that we're trying to return, the one that we're trying to return is visited. Well, the reason why, because we're just trying to collect the node, right? Visited node. All right, so node, and that's our answer. So 3210 is our solutions, right? Okay, so that's our solutions for depth first search in adjacency matrix, and that's our node that we visited from root to every node. Okay, enter, control and enter, and it worked correctly. So there you go.